The morning of August 15th, 1944, near Cherbourg, occupied France, Hauptmann Friedrich Weber stood beside a freshly excavated trench, staring at something that defied every principle of wartime logistics he understood. 16 inches of American steel pipe, welded joints still warm to the touch, stretching east toward the front lines as far as his field glasses could follow. Through his headphones, he could hear the steady thrum of pumping stations, a mechanical heartbeat that shouldn't exist this far from any refinery, this far from any port, this far from anything that made sense. Weber was a petroleum engineer. When the Wehrmacht recalled him in 1943, they assigned him to the 7th Army's Fuel Logistics Division for strategic analysis. He learned quickly that fuel wins wars. You don't fight based on courage alone. You fight based on what gasoline you can deliver to your tanks, what aviation fuel you can supply to your aircraft, what diesel you can provide for your supply trucks. Without fuel, the best army in the world becomes a collection of immobile metal. The German fuel situation in August 1944 was catastrophic. Romanian oil fields captured by the Soviets, synthetic fuel plants bombed by American daylight raids, fuel convoys destroyed by Allied fighter bombers on every road from the Rhine to Normandy. The Wehrmacht was rationing gasoline by the litre, prioritizing tanks over trucks, aircraft over vehicles, movement over everything else that required petroleum. Weber had calculated the mathematics precisely. The American advance would stall within 6 weeks, not because of German resistance, not because of strategic brilliance, because the Allies couldn't solve the fundamental problem of fuel supply over continental distances. Cherbourg to Paris, 300 kilometers. Paris to the German border, 400 kilometers. Every kilometer required fuel. Every tank, every truck, every jeep, every aircraft needed gasoline, delivered from England, across the English Channel, through destroyed French ports, along bombed roads, past German artillery positions. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The German calculations seemed mathematically unassailable. Fuel consumption rates for Allied armor: 15 gallons per hour for a Sherman tank under combat conditions, transport capacity of available tanker trucks, 2,000 gallons per convoy, road distance from functional ports to frontline positions, average 400 kilometers. Fuel required for the transport vehicles themselves, 20% of cargo capacity consumed by the journey. Weber had written detailed reports. The Allied advance would reach maximum extension by September 1st. After that point, fuel shortages would force consolidation. German counterattacks could exploit extended supply lines. The Wehrmacht needed to hold defensive positions until Allied logistics collapsed under their own weight. But standing beside that pipeline trench, listening to the mechanical rhythm of pumping stations, Weber understood that certainty could be the most dangerous weapon in war. Because once you became certain something was impossible, you stopped looking for ways to make it possible. And that's when the enemy surprised you with something you never imagined they could build. Weber knelt beside the pipeline, running his hand along the welded seam. American steel, probably Pittsburgh Mills, 16-inch diameter, wall thickness, approximately 3/8 of an inch, capable of handling pressures up to 800 pounds per square inch. This wasn't temporary field construction. This was permanent industrial infrastructure, built for continuous operation under maximum pressure conditions. He followed the pipeline east for 2 kilometers, taking measurements, making sketches in his field notebook. Every 500 meters, he found valve stations, standardized design, identical components, same control mechanisms. Every 2 kilometers, pumping stations, diesel engines, centrifugal pumps, pressure gauges, flow meters, industrial equipment that belonged in a peacetime refinery, not in a combat zone 60 kilometers from the front lines. The pipeline construction was systematic, methodical, engineered for efficiency rather than speed. But the speed was what made Weber's calculations seem obsolete. He timed the construction crews. American engineers laying pipe at an average rate of 8 kilometers per day, not 8 kilometers total, 8 kilometers of completed, welded, pressure-tested operational pipeline every single day. Weber opened his field notebook, calculated distances. Cherbourg to frontline positions, approximately 400 kilometers. At 8 kilometers per day, complete pipeline construction in 50 days. 50 days to build a fuel distribution system that could supply the entire Allied advance without depending on vulnerable truck convoys, without relying on bombed roads, without accepting the 20% fuel loss that made long-distance transport mathematically impossible. He thought about German pipeline construction. The Wehrmacht had built pipelines in Russia, connecting captured oil fields to German positions. Each pipeline required detailed surveys, custom engineering, specialized welding crews, months of construction time. A 100-kilometer pipeline took 6 months to complete, required constant maintenance, needed permanent security detachments to prevent sabotage. The Americans were building pipelines faster than Germany could destroy them. Even if German artillery targeted every pumping station, even if Luftwaffe bombers hit every valve installation, the Americans could rebuild the damaged sections within days. This wasn't just pipeline construction. This was industrial warfare on a scale that German logistics couldn't match. Weber counted the construction teams, 47 men working on this sector alone. Pipe layers, welders, equipment operators, pressure testers, quality control inspectors, each team specialized in one aspect of construction. No man needed to understand the entire system, just his specific role within the larger process. He watched the welding teams. 2 soldiers per joint. 1 positions the pipe, 1 operates the welding equipment. Automatic welding systems, not manual flame welding. Consistent penetration, uniform bead pattern, standardized quality control. No skilled craftsmen required. Just trained operators following established procedures. The pipe sections were identical. 20-foot lengths, beveled ends, standardized wall thickness. Every section manufactured to exact specifications, interchangeable with every other section. No custom fitting, no field modifications, no specialized components for difficult terrain. If the standard 20-foot section didn't fit the ground conditions, the engineers modified the ground to fit the pipe. Weber thought about the logistics required. Each 20-foot section weighed approximately 800 pounds. 400 kilometers of pipeline required 20,000 sections, 16 million pounds of steel pipe, transported from American mills, shipped across the Atlantic, unloaded at English ports, transferred to invasion barges, landed on Normandy beaches, trucked to construction sites, all while fighting a war, all while supplying ammunition, food, medical supplies, replacement equipment to armies advancing across France. The pipeline represented surplus logistics capacity. The Americans had solved their basic supply problems so efficiently that they could afford to build permanent infrastructure in an active combat zone. Weber walked back to the pumping station, examined the equipment more carefully. Twin diesel engines, each capable of 800 horsepower output, centrifugal pumps rated for 2,000 gallons per minute flow rate, pressure regulation systems maintaining constant flow regardless of downstream demand variations. The pumping station was automated, no operators required except for maintenance and emergency procedures. The system regulated itself, responded to pressure changes, compensated for flow variations, maintained optimal operating parameters without human intervention. This was technology that most civilian refineries didn't possess. The Americans were deploying it in field conditions 60 kilometers from German artillery positions. Weber calculated capacity, 2,000 gallons per minute equals 120,000 gallons per hour. 24 hours per day equals 2.8 million gallons. Daily capacity per pumping station. He counted pumping stations within his observation area. 7 installations visible from elevated positions, 7 stations times 2.8 million gallons equals 19.6 million gallons. Daily theoretical capacity. Enough fuel to supply every Allied tank, truck, aircraft, and support vehicle across the entire Western Front. No rationing required, no prioritization decisions, no mathematics of scarcity, unlimited fuel availability for the duration of combat operations. German fuel production in August 1944 was approximately 50,000 gallons per day from remaining synthetic fuel plants. The Americans were building pipeline capacity to deliver 400 times more fuel than Germany could produce. This wasn't logistics. This was industrial domination. Weber examined the pipeline route more carefully. The Americans hadn't simply laid pipe across existing terrain. They had engineered the route for optimal efficiency. River crossings used standardized underwater techniques. Hill sections included pressure release valves. Valley crossings incorporated expansion joints for thermal variation. Every potential failure point had been anticipated and engineered. Every stress concentration had been calculated and reinforced. Every maintenance requirement had been planned and supplied. The Americans weren't building temporary field expedients. They were building infrastructure designed to operate continuously for years. He found the valve control stations every 5 kilometers, manual override capability, pressure monitoring equipment, flow measurement devices, emergency shutdown systems. Each station was identical, used the same components, required the same training to operate. A technician trained on one station could operate any station along the entire pipeline system. Weber thought about training requirements. To build a German pipeline, you needed petroleum engineers with university education, certified welders with years of experience, pump operators with specialized technical knowledge, maintenance crews with detailed understanding of complex systems. To build an American pipeline, you needed soldiers trained in standardized procedures. Train a man to weld one joint correctly, he can weld every joint on the pipeline. Train a team to install one pumping station. They can install hundreds of identical stations. Train operators on standardized equipment. They can work anywhere along the system. The Americans had eliminated the need for expertise by creating systems so standardized that basic competence was sufficient. This was the fundamental difference between German engineering precision and American industrial efficiency. German systems were elegant, customized, optimized for specific conditions, and required experts to operate. American systems were standardized, mass-produced, designed for operation by trained soldiers rather than educated engineers. In peacetime, the German approach produced superior results. In wartime, the American approach produced superior logistics. Weber returned to his command post at 1800 hours. The major was studying fuel allocation reports, calculating rations for the next week's operations. The mathematics were brutal. 5,000 gallons available. Tank battalion required 8,000 gallons. Artillery tractors needed 2,000 gallons. Supply trucks demanded 3,000 gallons. Total requirements exceeded supply by 8,000 gallons. Report Hauptmann. Weber opened his field notebook, reviewed his observations. Herr Mayer, the Americans have constructed a pipeline system capable of delivering approximately 20 million gallons of fuel per day to frontline positions. The system is operational now and expanding eastward at 8 kilometers per day. The major stopped writing, looked up from the allocation reports. 20 million gallons per day. Yes, Herr Major. I observed 7 pumping stations in my sector alone, each station capable of 2.8 million gallons daily throughput. The system extends from Cherbourg to current frontline positions, approximately 400 kilometers of 16-inch high-pressure pipeline. The major stared at the fuel allocation reports. 5,000 gallons available, 20 million gallons flowing through American pipelines. The mathematics were impossible to ignore. What does this mean for our defensive strategy? Weber had thought about this during his walk back to headquarters. Herr Mayer, our defensive planning assumes Allied fuel shortages will limit the advance. Extended supply lines, truck convoy, vulnerabilities, fuel rationing, forcing operational pauses. The pipeline eliminates these constraints. The Americans can advance continuously without fuel considerations. Yes, Herr Major. Unlimited fuel availability means unlimited operational flexibility. They can maintain maximum advance rates, conduct simultaneous operations across multiple sectors, deploy armor without range limitations, operate aircraft at maximum sortie rates. The Major sat quietly for several minutes, processing the implications. German defensive strategy had been built around exploiting Allied logistics vulnerabilities, force them to extend supply lines beyond sustainable limits, attack fuel convoys, destroy bridges to create transportation bottlenecks, wait for logistics collapse to create opportunities for counterattack. If the Americans had solved the fundamental fuel supply problem through permanent infrastructure, the German strategy was obsolete. No fuel shortages meant no logistics vulnerabilities. No transportation bottlenecks meant no forced operational pauses. No supply line weaknesses meant no counterattack opportunities. Weber continued his analysis. The pipeline represents industrial capacity we cannot match, Herr Major. Construction requires thousands of tons of steel pipe, hundreds of pumping stations, specialized welding equipment, trained personnel, continuous supply of construction materials. Could we build a similar system? Weber had calculated this possibility during his observations. Theoretically possible, but practically impossible. Our steel production is insufficient for pipeline construction while maintaining tank and ammunition production. Our fuel supplies are inadequate for operating the pumping stations. Our transportation system cannot deliver construction materials to forward positions under constant air attack. The Major understood immediately. Germany could not build what the Americans had built, not because the engineering was too complex, not because the technology was unavailable, but because Germany lacked the industrial base to support such construction while fighting a war on multiple fronts. Recommendations, Hauptmann? Weber had thought about tactical responses during his return march. Herr Major, direct attacks on the pipeline are ineffective. The Americans repair damage within hours using standardized replacement components. Artillery bombardment of pumping stations is temporary. They rebuild installations faster than we can destroy them. Then how do we counter this system? We cannot counter the system itself. We can only attempt to counter the advantages it provides. Focus defensive efforts on terrain that negates mobility advantages, channel American advances into prepared killing zones. Force infantry combat in urban areas where fuel availability provides minimal tactical benefit. The Major nodded, understanding the strategic reality. Germany could not match American industrial capacity. Germany could not build comparable supply systems. Germany could only attempt to create conditions where American advantages were neutralized through superior defensive positions and tactical expertise. But both officers understood the fundamental mathematics. An army with unlimited fuel could sustain operations indefinitely. An army with limited fuel was fighting on borrowed time. The pipeline ensured that time was on the American side. Weber wrote his detailed report that evening, documenting every observation, recording every measurement, calculating every implication. The pipeline represents a paradigm shift in military logistics. The system eliminates traditional supply line vulnerabilities and enables sustained operations over continental distances. He paused, considering the strategic implications. American fuel capacity exceeds German production by 400 to 1. This ratio cannot be overcome through tactical innovation or operational efficiency. The gap is industrial and therefore unbridgeable under current conditions. Weber signed the report, knowing it would travel up the chain of command, knowing each level would add comments and modifications, knowing that by the time it reached decision makers, the Americans would have extended their pipeline another 100 kilometers toward Germany. The events of the following months validated Weber's assessment with mathematical precision. By October 1st, the American pipeline system extended from Cherbourg to Metz, over 600 kilometers of operational infrastructure, delivering fuel directly to armored divisions approaching the German border. By December 1st, multiple pipeline branches supplied separate army groups, creating redundant fuel distribution networks that could not be disrupted by tactical German attacks. By February 1945, American pipeline capacity exceeded 200 million gallons monthly, supporting the final offensive that broke German defensive lines and crossed the Rhine. If you find this story engaging, Please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The pipeline system, officially designated the pipeline under the ocean, eventually extended over 2,000 miles from refineries in England under the English Channel, across France, through Belgium, and into Germany itself. Construction required over 400,000 tons of steel pipe, 800 pumping stations, and 15,000 trained personnel. But the deeper achievement extended beyond engineering statistics. The pipeline represented American confidence in industrial warfare. The Allies weren't just building enough equipment to win battles. They were building infrastructure to support operations on a continental scale, building supply systems for military operations that would cross Europe and defeat Germany through sustained logistic superiority. Weber survived the war, was interrogated by Allied intelligence officers in May 1945. They asked him about German assessment of American supply capabilities. Did you believe we could build the pipeline system? Weber remembered that August morning in 1944, standing beside the 16-inch pipe, calculating impossibilities that had become realities. No, he said finally. I didn't believe it was possible to build such infrastructure while fighting a war, but I watched the construction proceed and I understood the Americans weren't building temporary expedients. They were building permanent systems designed to operate for decades. What was the most surprising aspect? Weber thought about the standardization, the systematic engineering, the industrial confidence that treated a 2,000-mile pipeline as a routine logistics problem. The speed, he said. German engineering focused on perfection, custom solutions for specific problems. American engineering focused on efficiency, standardized solutions that could be mass-produced and rapidly deployed. Which approach was superior? Weber considered the question carefully. In peacetime, German engineering produced superior individual systems. In wartime, American engineering produced superior logistics. War is about supply, not perfection. The pipeline under the ocean operated continuously from August 1944 through the end of the war, delivering over 600 million gallons of fuel to Allied forces. It enabled the rapid advance from Normandy to the Rhine, supported the Battle of the Bulge logistics, and supplied the final offensive that crossed Germany and met Soviet forces at the Elbe River. After the war, sections of the pipeline were converted to civilian use, supplying fuel to reconstruction efforts across Western Europe. Some sections remained operational into the 1950s, a permanent reminder of American industrial capacity deployed for military purposes. But the deepest lesson of the pipeline system extended beyond logistics achievement. It demonstrated that modern warfare was fundamentally industrial warfare, decided not by tactical brilliance or strategic genius, but by the capacity to produce and deploy resources faster than enemies could consume or destroy them. The Germans had been correct about one fundamental principle: fuel wins wars, but they had been wrong about American capacity to solve fuel distribution problems through permanent infrastructure construction. They had calculated that continental distances made supply impossible. The Americans had calculated that continental distances made pipelines necessary. The difference between those calculations revealed the gap between defensive thinking and offensive thinking, between solving problems through rationing and solving problems through production, between accepting constraints as permanent and treating constraints as engineering challenges. Weber understood this in that moment beside the 16-inch pipeline, listening to the mechanical rhythm of pumping stations. The Americans hadn't just built a fuel distribution system. They had built confidence in industrial solutions to military problems. They had proven that with sufficient resources, sufficient organization, and sufficient willingness to think systematically, any logistics problem could be solved through engineering. The pipeline was proof that the greatest weapon in modern warfare was not superior tactics or advanced technology, but superior production capacity applied systematically to support continuous operations. The moment you accepted that fuel shortages were inevitable, you started planning defensive operations. The moment you decided that fuel shortages were engineering problems, you started building pipelines. Germany accepted constraints, America engineered solutions. That fundamental difference in thinking, more than any tactical or strategic factor, determined the outcome of the war. The Americans won because they refused to accept logistical limitations as permanent conditions. They won because they treated every supply problem as an industrial challenge that could be solved through systematic application of resources and engineering expertise. The pipeline under the ocean represented American confidence that any problem could be solved through sufficient application of industrial capacity. It represented the faith that motivated American war production, the belief that enough steel, enough labor, enough systematic planning could overcome any obstacle, could build any system, could supply any army anywhere in the world. That faith proved justified. The pipeline delivered fuel when and where it was needed, enabled operations that would have been impossible through conventional supply methods, and demonstrated that modern military power ultimately depended on industrial power systematically applied to support strategic objectives. Weber learned that certainty about impossibility was the most dangerous limitation in warfare. The moment you decided something couldn't be done, you stopped trying to do it. The Americans never stopped trying to solve their supply problems, and that persistence, more than tactical genius or strategic brilliance, ensured their victory. The greatest lesson of the pipeline under the ocean was not engineering achievement, but psychological achievement. The demonstration that with sufficient determination, sufficient resources, and sufficient systematic thinking, any logistical challenge could be overcome through industrial methods. The Americans built more than a pipeline. They built confidence in American industrial capacity to support any military operation anywhere in the world. Weber's observations in August 1944 represented only the beginning of American pipeline expansion across Western Europe. What he witnessed near Cherbourg was merely the first phase of an integrated fuel distribution network that would ultimately revolutionize military logistics forever. By September 1st, 1944, American pipeline construction had accelerated beyond Weber's initial calculations. The 8 kilometers per day rate he had observed increased to 12 kilometers daily as construction crews gained experience and equipment improved. Mobile welding units, standardized pipe-laying machinery, and prefabricated pumping stations enabled faster deployment across increasingly difficult terrain. The pipeline system expanded in multiple directions simultaneously. The main trunk line extended eastward toward Paris. Following the advancing Allied armies, branch lines split off to supply specific sectors, creating redundant fuel distribution networks that could continue operating even if individual sections were damaged or destroyed by German artillery. Weber received daily intelligence reports about American construction activity. The scope was staggering. Parallel pipeline construction in the British sector created a second trunk line from Courseulles-sur-Mer to Caen, then onward toward Brussels. Combined, American and British pipeline capacity exceeded 30 million gallons daily by October 1st, representing more fuel than Germany had consumed during entire months of the war. The Americans weren't simply building pipelines. They were constructing an integrated fuel infrastructure that treated Western Europe as a single logistics theater. Storage facilities, distribution centers, pumping stations, control systems, maintenance depots, all connected through standardized equipment and procedures that enabled centralized management of fuel resources across hundreds of kilometers. Weber studied captured American technical manuals, trying to understand the engineering principles behind such massive construction projects. The manuals revealed systematic thinking that German engineering culture couldn't match. Every component was standardized, every procedure was documented, every possible failure mode was anticipated and planned for. American pipeline construction used modular components manufactured in the United States, shipped to England, then transported across the Channel as needed. Pumping stations came in standardized configurations, completely assembled and tested before deployment. Valve systems, pressure regulators, flow meters, control equipment, all manufactured to identical specifications that ensured interchangeability across the entire network. The maintenance philosophy was entirely different from German approaches. German systems were designed for durability, built to last decades with minimal maintenance. American systems were designed for replaceability, If a pumping station failed, they didn't repair it. They replaced it with an identical unit and sent the damaged equipment to rear area facilities for overhaul. This approach required massive logistics support, but provided operational advantages that German methods couldn't match. No specialized repair skills needed at forward positions, no custom parts required for specific installations, no complex diagnostics necessary for troubleshooting. Standardized replacement components meant that maintenance became a simple substitution process. Weber calculated the industrial capacity required to support such operations. Each pumping station contained components worth approximately $50,000 at pre-war prices. The Americans had deployed over 300 pumping stations by December 1944, representing $15 million in specialized equipment dedicated solely to fuel distribution infrastructure. $15 million spent on equipment that might be abandoned or destroyed when the front advanced beyond its usefulness. This was industrial confidence on a scale that German war production couldn't comprehend. Germany was rationing steel for tank production. The Americans were building temporary infrastructure worth more than entire German industrial facilities. The pipeline system enabled operational capabilities that changed the fundamental nature of mobile warfare. American armored divisions could advance continuously without pausing for fuel resupply. Tank battalions could conduct extended operations without range limitations. Supply trucks could carry ammunition and food instead of fuel, increasing combat logistics efficiency. Most significantly, the pipeline eliminated German interdiction opportunities. No fuel convoys to attack, no supply depots to destroy, no transportation bottlenecks to exploit. The fuel simply appeared at forward positions through underground infrastructure that German artillery couldn't effectively target. Weber observed American fuel consumption patterns through intelligence reports from forward positions. Allied forces were operating vehicles at maximum utilization rates without conservation considerations, tanks idling continuously to maintain battery power, supply trucks making multiple trips daily without fuel rationing, aircraft conducting maximum sortie operations without range restrictions. German forces were calculating every liter, prioritizing fuel allocation among competing requirements, rationing consumption to extend operational capability. The mathematics of scarcity versus the mathematics of abundance. Two armies fighting the same war under completely different resource constraints. The psychological impact on German soldiers was devastating. Captured American equipment revealed fuel systems that German troops had never seen. Auxiliary fuel tanks, fuel heating systems, fuel filtration equipment, fuel transfer pumps. Americans had so much fuel they could afford to use it for convenience features that German soldiers considered impossible luxuries. Weber examined captured American fuel quality standards, octane ratings higher than German aviation gasoline, additive packages for cold weather operation, specialized lubricants for extreme operating conditions. The Americans weren't just delivering more fuel, they were delivering better fuel, optimized for maximum equipment performance under combat conditions. German fuel quality had declined continuously throughout the war. Synthetic fuel production created lower octane gasoline that reduced engine performance. Additive shortages eliminated cold weather operability. Contamination from damaged storage facilities caused equipment failures. German soldiers were fighting with degraded fuel, while American soldiers operated with premium fuel optimized for maximum performance. The contrast extended to fuel handling equipment. American forces used standardized fuel transfer systems, electric pumps, heated fuel lines, filtration equipment that prevented contamination. German forces used manual pumps, gravity feed systems, improvised containers that frequently introduced contamination and reduced fuel quality. Weber realized that the pipeline represented more than logistics infrastructure. It represented systemic thinking about industrial warfare. The Americans had analyzed fuel requirements, identified constraints, and engineered comprehensive solutions that addressed every aspect of petroleum logistics, from refinery to tank engine. German fuel systems had evolved reactively, solving immediate problems without systematic integration. Each solution was optimized for specific requirements without considering broader system interactions. Refineries, transportation, storage, distribution, utilization, all managed separately without unified planning or standardized procedures. American fuel systems were designed systematically from the beginning. Every component was engineered to work with every other component. Refinery output specifications matched pipeline pressure ratings. Pipeline capacity matched pumping station throughput. Storage facility design matched distribution requirements. Vehicle fuel systems matched available fuel quality standards. The result was a seamless fuel supply chain that operated automatically without constant management attention. German fuel systems required continuous oversight, constant problem-solving, continuous adaptation to changing conditions. American fuel systems required only routine maintenance and standard operating procedures. By January 1945, American pipeline networks extended from channel ports to the German border, over 800 kilometers of operational infrastructure, delivering fuel directly to armored spearheads, preparing for the final assault on Germany itself. Branch pipelines supplied individual army groups, creating redundant fuel distribution that could support simultaneous operations across multiple sectors. Weber calculated that American fuel capacity exceeded German requirements, even if Germany had captured the entire pipeline system intact. The Americans were delivering more fuel than Germany could use, even with unlimited access to American petroleum resources. This wasn't logistics planning. This was industrial demonstration. The pipeline system enabled the rapid advance that broke German defensive lines in the Rhineland, supported the crossing of the Rhine River itself, and supplied the final offensive that crossed Germany and linked up with Soviet forces advancing from the east. Without unlimited fuel availability, such sustained operations across continental distances would have been impossible. American forces advanced continuously from the Rhine to the Elbe River without operational pauses for refueling, without supply line consolidation, without logistics limitations that had constrained every previous military campaign in European history. The pipeline had eliminated the friction of distance that Clausewitz had identified as the fundamental constraint on military operations. Weber understood that he had witnessed the transformation of warfare itself. Industrial capacity applied systematically to solve logistics problems had created military capabilities that exceeded any previous army in history. Not better soldiers, not superior tactics, not advanced technology, but superior supply systems that enabled continuous operations on a scale that German military thinking couldn't comprehend. The pipeline under the ocean demonstrated American confidence that any problem could be solved through sufficient application of industrial resources. It proved that systematic engineering could overcome any constraint, could build any system, could supply any army anywhere in the world for any duration required to achieve victory. This was the fundamental lesson that Weber learned from his observations in 1944. Modern warfare was industrial warfare. Victory belonged to the nation that could produce and deploy resources faster than enemies could consume or destroy them. The Americans had proven that industrial superiority, systematically applied, could solve any military problem. The Germans had lost the war not on the battlefield, not through strategic failure, not because of tactical incompetence, but because they could not match American industrial capacity deployed for military purposes. The pipeline was proof of American ability to think systematically about complex problems and engineer comprehensive solutions that exceeded anything Germany could build or destroy. Weber's final assessment, written after his interrogation by Allied intelligence officers, captured the essential truth about industrial warfare. The Americans won because they built systems that solved problems permanently rather than temporarily. German engineering focused on elegant solutions to specific problems. American engineering focused on systematic solutions that eliminated entire categories of problems. The pipeline under the ocean eliminated fuel supply as a constraint on military operations. It proved that with sufficient resources, sufficient organization, and sufficient systematic thinking, any logistics challenge could be overcome through engineering. The Americans didn't just build a pipeline. They built confidence in American industrial capacity to support any military objective anywhere in the world. That confidence, more than tactical skill or strategic genius, ensured American victory in World War II and established the foundation for American military power that would shape global affairs for decades to come. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.